Adam, I advise you to use Isaac.
Sorry?
I advise you to use Isaac to help you.
Okay, thank you. Isaac, can you put up your hand such that I can make you a co-host? I think it's Isaac Semakula, right? Isaac, please raise your hand such that you'll help me coordinate the chat and the people who will have raised their hands. Okay, so also as we do that, can we have someone raise their hand so that they can lead us in a word of prayer? Let's hear from Flavia. Please pray for us. Flavia, please unmute and pray.
Dear Lord, our
Let's pray. Mighty Father, I thank you for today. I thank you for this lesson that you are going in. Lord, I pray I welcome you, King of Glory, to come and guide us and help us, King of Glory, and help us understand every concept that we are going to study about. I will invite you, Holy Spirit, to dwell within us, King of Glory, and be with us throughout this lesson, Jesus Christ. In the name of Jesus Christ, we have prayed. Amen.
Amen. Thank you so much, Isaac. I don't know what happened to Flavia's network. So we are going to study chemistry, but before we do that, I just want to share with us today's word. It says, you have the wisdom of God. Proverbs chapter 3 verse 13 says, happy is a man who finds wisdom and the man who gains understanding. Wisdom comes from the Lord. The Bible says in 1 Kings chapter 4 verses 29, and God gave Solomon an exceedingly great understanding. Solomon was renowned as the wisest and richest man of his time because God's wisdom was working in him. But here is the amazing news. You have something greater. When you were born again, the Holy Spirit made his temple and he became your wisdom. With God's wisdom, you will always know what to do. You will make the right choices, speak with understanding, and stand out in all you do. Keep growing in wisdom by studying God's word. And remember, when you speak, let God's wisdom be heard in your words. We can take on the prayer. I operate in the wisdom of God, walking in divine understanding. His wisdom guides me in every decision, ensuring that I always choose the right path. In Jesus' name, amen. Thank you for listening. So today our lesson, I saw the different topics that people posted, but in order to be uniform, if you studied the topic, it's well. If you didn't study it, it's still okay, but we can still contribute with each other. So I started with the topic of senior 3 third term. I know some people might have covered it already, while some may not have covered it. So to be at the same pace, we are all going to look at that topic for senior 3 third term, the very first topic, which is called fossil fuels. So that is what we are going to engage with today. Let me just share my screen. I hope we are all able to see my screen. So we are going to be looking at fossil fuels, and of course, I'll be asking us questions here and there. So we are expected to know what we need to know at the end of that topic. So that means as we go about this topic, we are expected to have this in our mind, and I want to request someone to raise their hand so they can read it for us. Isaac, you can choose one person to read for us what is on the board.
Zuriel, please unmute. Okay, sure. Yes, Zuriel, unmute.
Understand the types and origins of fossil fuels, why they can be used as sources of energy and useful materials.
Okay, thank you so much. So by the end of this chapter, you're expected to understand the types and origins of fossil fuels. As we are going to see, we are going to understand what are fossil fuels, what are some of the types, and what are their origins. And then, of course, why are they used as sources of energy or used in various materials? So as we go about this topic, you should have those as your highlighted points. Because I know most of us have done activities of integration, and you realize that as you go about those activities of integration or the scenario, these are the key things that are pointed out in what? In those questions. So who can share with us what they think fossil fuels are? You can post in the chat or you can raise your hand and you tell us what you think fossil fuels are.
Josiah, unmute. Sumaya.
So a fuel, according to me, a fuel is a combustible substance that produces useful energy when it undergoes a chemical reaction by burning it in oxygen or through a nuclear reaction.
Okay, that is very good. Anyone else?
Sumaya, go on.
Okay. Fuels, fossil fuels are fuels which support burning in terms of they can also produce carbon dioxide and I forgot,
Okay, that is good. Anyone else?
Good afternoon, madam.
Good afternoon.
In my opinion, fossil fuel refers to products that are formed from slow decomposition of remains of plants and animals that have lived millions of years ago.
Okay, thank you. That is good. Okay, so I think we'll move with those answers. Thank you everyone for your contributions, even the ones in the chat. So when we are talking about fuels, we are basically looking at those substances that can be used to produce energy, maybe by combustion or by nuclear processes, but basically we are looking at those substances that can generate energy. So I think someone defined what fossil fuels are, so we'll just dive straight into what the definition is. So when we are looking at fossil, what is a fossil? Most of us that have looked at archaeology, archaeological activities, or even documentaries, I'm sure this word fossil fuels is not new to us. And basically, when you look at fossil fuels, there are those hydrocarbons. And I am sure most of us have covered carbon in life where you've looked at hydrocarbons. By now, you should know what a hydrocarbon is. So when you're looking at fossil fuels, there are those hydrocarbons that are formed by decayed plants and animals over millions of years. So that means this one is not going to take 2 years and then you call it a fossil. That means it has taken millions and millions of what? Of years for it to decay in order to be categorized as a what? As a fossil. But because they're a result of producing energy, and in that case, that's where the word of fuels comes in. So when you're looking at fossil fuels, you're basically looking at those hydrocarbons that are formed by decayed plants and animals over millions of what? Of years. And the time here is very important because if you say over many years, how many? Because 100 are many, 10 are many. So that means you need to be specific that over millions of years, because it has to take a million years and above for it to be considered in that context of what? Of being a fossil. Okay, so we also need to understand that fossil fuels are formed by natural processes such as anaerobic decomposition and energy from ancient photosynthesis of plants. So when you're looking at fossil fuels, they basically undergo natural processes. We're going to see the different fossil fuels and the types. You're going to notice one thing, that they are all decaying under natural processes. There is nothing like man inducing the what? Inducing their formation. So that means the formation basically of natural materials is a natural process. And we have a question here. Why do fossil fuels contain carbon? Anyone that has an idea on why we think fossil fuels contain carbon?
Teacher, I think that they contain carbon because they are formed from the remains of plants and animals that are mainly made up of carbon.
Josiah.
Okay, that is very good.
Second, please unmute.
They have organic matter.
Fossil fuels contain carbon because they are formed from the remains of ancient plants and animals.
Okay, thank you. Can we take one more hand?
Shari?
Madam, may I think that fossil fuels contain carbon because they are formed from the Earth's crust under natural processes for a long time.
Okay, thank you. All those are amazing answers. At least I can see one thing that is coming out is they are all formed from natural processes. And we know that most of these fossil fuels are as a result of decay of plants and animals. And when you look at the plants and animals, they have a major component, which is carbon. So that means even when they decay, the production of carbon is still there. That means these fossil fuels I don't know why I went off, but I was still saying when we are looking at fossil fuels, we are basically looking at those plant materials. And of course, when you're looking at the plant materials and animal materials, you realize that they contain carbon. That means when there is decay of those substances, the carbon is not going to just disappear. Even when they decay, it remains embedded from the places where they have decayed from. And that is why we find that these fossil fuels contain a lot of what? Carbon, other than any other element. So here we have they are formed from decomposition of buried carbon-based organisms that died millions of years ago. So before we go into the types of fossil fuels, we are going to watch a video on fossil fuels. So I hope you pay attention and take down some notes as we watch this video. Don't just sit and assume maybe you're watching a movie. Make sure to take down some notes because there are things I may not have mentioned, but they're important in the video. So please endeavor to take note.
Have you ever wondered how fossil fuels are formed, where they come from, and why they are important in our everyday lives? Fossil fuels have many uses and are all around us. Fossil fuels such as oil, natural gas, petroleum, and coal are all important non-renewable resources that come from sedimentary rocks. Oils are used to produce gasoline, which has various uses in our world. Vehicles use gasoline as a form of energy. This includes buses, trucks, motorcycles, and cars. These all use gasoline to operate. Natural gas is used for both heating and cooling a home, and also for cooking. Next time you're cooking your favorite meal, remember that this was made possible because of natural gas. Coal is inexpensive and is used around the world to help produce electricity. This electricity can then power your TV, your computer, and your favorite electronic device. So how are fossil fuels formed, and where did they come from? Fossil fuels were formed millions of years ago from dead organic materials such as plants and animals. Coal, oil, and gas were formed when these plants and animals died and sank to the bottom of the ocean. Over time, this dead organic material was covered by mud and other sediments. Pressure from layers of sedimentary rocks, along with heat, turned these dead animals and plants into coal, oil, and gas. Coal can be found in sedimentary rocks, while oil is found between layers of sedimentary rocks, such as shale. Natural gas usually is found in the form of methane, in pockets above deposits of oil. Over 80% of all the energy consumed in the United States comes from natural gas, coal, and oil. Can you think of 3 examples of how fossil fuels are used in your everyday life? Can you also think of how different life would be without fossil fuels? Let's review what we just learned. Fossil fuels such as oil, gas, and coal are all non-renewable resources that come from what was once dead organic material. Millions of years ago, these dead plants and animals were covered by mud and sediments. Over time, the heat and pressure from sediments turned this dead organic material into natural gas, coal, and oil. Natural gas, coal, and oil have many uses, such as creating electricity that powers our homes, cooking, and fuel for transportation. See you all next time.
Good evening and welcome to the greatest show on earth. This is a people's game.
Okay, so that was the video about fossil fuels. And of course, everything that was shared in that video is basically what we had shared earlier on. So unless someone has a question, I want us to look at the types of fossil fuels. Okay, seems everyone is on the same page. So we are going to be looking at types of fossil fuels. And our first type is coal. And maybe before we look at coal, what are the different types of fossil fuels? And since we've already mentioned coal here, let's mention the rest that we know.
John Mark.
Crude oil and natural gas.
Crude oil and
gas.
natural food. Any other?
Oil.
Oil, we've already mentioned crude oil. Okay, thank you. Any other?
Charcoal. Charcoal.
Or fossil fuel?
not supposed to. It's unmuted.
Coal is
Charcoal.
a fuel, but I don't think it's a fossil fuel because remember what we talked about concerning fossil fuels.
Natural gas.
So charcoal may not count.
Renewable.
Uranium.
So we have natural gas, we
Uranium.
have crude oil or petroleum.
Uranium.
Then we also have
Uranium.
natural gas and uranium. Someone is saying peat and tar gas. Okay. So those are the different fossil fuels that we have. So we are going to look at the first one as coal. We have a question here. How does coal look like and where is coal got from? Anyone with some answers?
Amrat. And okay, Josiah.
Coal is a black or brownish sedimentary rock with high amounts of carbon.
Okay, that is good.
Coal
Thank you,
is
Josiah.
black.
Any other?
Madam, coal is black and it's got from coal.
What I know about coal is that coal is a solid fuel. It's formed from ancient plants that have been subjected to high temperatures and pressure over millions of years.
Okay, that is good. Thank you.
In the chat, the Adrian is saying, basing on the video, it is found in sedimentary rocks. Irene says, I think coal is like burning hot charcoal and it is got from sedimentary rocks. Yes.
Okay, thank you for all those contributions. Thank you, Isaac, for coordinating. So all those answers are true, and when we merge them, they'll give us the actual outline of what coal really is. So depending on the amount of carbon in coal, coal is basically a black substance. But of course, we know that the level of carbon may differ. That's why some books may refer to it as a brownish black sedimentary rock. So since we looked at the video, like someone mentioned earlier on, that when these decomposed matter get into those rocks and they are squeezed under heat and pressure, you find that they form within those sedimentary rocks. And that is why we are saying coal is a combustible. That means it can be burnt. Black sedimentary rock with a high amount of carbon. But this doesn't mean that it doesn't have other elements, but the highest component in coal is what? Is carbon. For example, you will find this item when you're doing your exam in item 5 and 6. And of course, during those items, they expect you to give the components that are involved in that particular substance. So in that case, you can't leave out carbon because it's a major composition of what? Of coal. But like I said, of course, we have other elements within which are, can I get some answers on some of the other elements we can find in coal apart from carbon?
Maria.
In coal, you can find hydrogen, oxygen, nitrogen, and a few bits of sulfur.
Okay, that is good.
Caroline, in the chat, Irene says oxygen. Then the ITIL says nitrogen.
Okay, thank you. As if I've seen a question asking how can a rock burn? Anyone who has a question to that answer? Anyone that has a clue?
Yes, madam. Good afternoon.
Good afternoon.
Yeah, I think they are asking why. Okay, how can a rock burn? I think it is done through radiation, radioactivity in the rock.
Okay.
Madam,
I
think rocks like coal can burn because they contain combustible organic materials such as carbon and hydrocarbons. When they are heated, these materials react with oxygen, releasing energy in form of heat and light.
Okay, that is very good. I can't say anything better. So I think Infinix, you've got your answer right there. Okay, so we move on. Coal is a non-renewable energy source. Why? Why do we call coal a non-renewable energy source?
Try, madam.
Yes, please.
Coal is referred to as a non-renewable resource because once used, it cannot be replaced by natural resources.
Okay, thank you. Any other?
Madam.
Madam.
It takes
Of course,
millions of years to form from the remains of ancient plants and animals.
Okay, that is good. Any other?
Madam. Madam.
Madam.
Not be regained. Once exhausted, it cannot be regained.
Okay, that is good. Any other?
Madam, I think coal is a non-renewable because it takes millions of years to be formed.
Okay, that is good. Okay, so I think those are some of the reasons why, because we know non-renewable sources of energy basically take several years in order to form. So that means when they are exhausted or when they get done or when they are used up, it will take you again other millions of years for them to what? To form. That's why we call them non-renewable. So that means for us to form coal again, if we exhaust the coal we have currently, it will take us again millions of years to obtain that what? That coal. Hence making it non-renewable. So some people may use replaced, cannot be replaced easily. It will take millions of years. While other people may use replenished. But if you feel you can't spell that word, it's better you use replaced. Okay, so we have the formation of coal. And of course, we said it comes from decaying of plant material. So when this plant material decays, that is what we call peat. So when it decays and it takes several years, of course, under the several years, it's decaying within the ground. So that means as it decays, it's going to take those millions of years. And as those millions of years go on, you're going to find that there is a lot of pressure, there is a lot of heat being released, and therefore they are going to compress that decayed matter into what we call lignite. And of course, as time keeps going on, you're going to find that coal is being deposited within those sedimentary rocks. So we are going to watch a video on the formation of coal. Maria, can you please mute your mic? Thank you. So we are going to watch two videos basically on coal. But as I said in the first video, ensure that you're taking down notes such that you're able to revisit those things even after this lesson.
There are few natural resources which have had the massive and sudden impact that coal has had. Instead of burning organic matter like trees for fuel, people were able to burn organic matter from the past, and the rest is history. So how is coal formed? Plants, like plants always do, die, and some of them get stuck in stagnant water, like swamps for example. Unlike moving water such as rivers, stagnant water doesn't have much oxygen. And because there's no oxygen, instead they're preserved, and over long periods of time, layers of sediment are deposited on top. Then, under heat and pressure, in a process called diagenesis, or specifically in this case, coalification, the plants are compressed into peat, and then eventually into coal. This entire process is very slow and takes millions of years. The heat and pressure remove the hydrogen, nitrogen, and oxygen until only the carbon remains. The higher the rank of coal, the higher the carbon content, the shinier it is, the blacker it is, and the greater it burns. And until next time, thanks for watching. Resources which have had the There are few natural resources which have had the massive and sudden impact that coal has had. Instead of burning organic matter like trees for fuel, people were able to burn organic matter from the past, and the rest is history. So how is coal formed? Plants, like plants always do, die, and some of them get stuck in stagnant water, like swamps for example. Unlike moving water such as rivers, stagnant water doesn't have much oxygen. And because there's no oxygen, instead they're preserved, and over long periods of time, layers of sediment are deposited on top. Then, under heat and pressure, in a process called diagenesis, or specifically in this case, coalification, the plants are compressed into peat, and then eventually into coal. This entire process is very slow and takes millions of years. The heat and pressure remove the hydrogen, nitrogen, and oxygen until only the carbon remains. The higher the rank of coal, the higher the carbon content, the shinier it is, the blacker it is, and the greater it burns. And until next time, thanks for watching.
Of all the
So when you look at that video, it was basically explaining what we had just shared. So this one is going to really show us how coal is extracted even from the mine. So I just want you to pay some close attention to it. Then we'll wrap up on coal and maybe look at something else if time allows us to.
the energy sources currently in use on planet Earth, none have such a long history or deep controversy as coal. As one of the earliest sources of energy, coal has proved to be a reliable performer over time, but carries some concerns when it comes to air pollution and climate change. As economist Thomas Sowell put it, there are no solutions, there are only trade-offs. And so when it comes to producing the electricity that we all enjoy as a part of our modern lifestyle, is the trade-off of coal sustainable? How much of the electricity generated today is powered by coal, And will it ever become obsolete? We seek to answer these questions and more on today's episode of Commodity Culture. Coal begins its life as a giant plant in a prehistoric swamp hundreds of millions of years ago, before even the mighty dinosaur roamed the earth. As that plant and many others around it dies and becomes submerged in the swampy environment, geological forces subject them to heat and pressure over time. This causes the dead plant matter to transform. What began as a moist and low-carbon form of peat is now energy and carbon-dense coal, and a sort of life and death cycle has taken place. From living plants to dead plant matter, and then into an energy-rich rock that is at the heart of humanity's rapid technological progress over the ages. Now, depending on how much time has passed since the swampy peat matter began its metamorphosis, it will have turned into one of 4 different categories of coal. Lignite contains 25 to 35% carbon and is the least energy-dense form of coal. It is a crumbly substance and is high in moisture, so has a suboptimal heating value. It is mostly used to generate electricity, but it can also be converted into a form of synthetic natural gas, chemically similar in most respects to the real thing, and so can be substituted or used interchangeably. Subbituminous coal bumps the carbon up a notch with a 35 to 45% quantity. The average age of this variety of coal is at least 100 million years old, but averages a very elderly 251 million years of age. The last note I'll make on subbituminous is that it's also mostly used for electricity generation. Bituminous coal starts to really bring the carbon, with a density of 45 to 86%. This is the main form of coal produced in the U.S., accounting for approximately 48% of U.S. coal production as of 2019. In addition to following in its siblings' footsteps and being used for electricity, it also is a raw material for making the 5th category of coal, which doesn't exist naturally, called coking coal. Coking coal is made use of as a fuel and a reducing agent in smelting iron ore in a blast furnace. Anthracite contains 86 to 97% carbon and has the highest heating value amongst all ranks of coal, and is also smokeless and pollutes the least. It is mainly used for metallurgical purposes, but also finds some use as a heating fuel. All the varieties of coal contain sulfur in varying degrees, which releases toxins into the air when burned. Interestingly, the sulfur content is dictated by the environmental conditions in which the coal was created. Freshwater environments breed low sulfur coal, while brackish swamps and marine-influenced environments produce a high sulfur variety. Coal, like all fossil fuels, is composed of carbon and hydrogen. When combusted, the carbon forms harmful carbon dioxide and the hydrogen becomes water. Coal has a greater quantity of carbon than, say, oil or natural gas, and so causes more damage to the environment overall.
To the woman who hasn't stretched in a decade on Monday, September 1st. Tomorrow morning, we're...
When we trace the history of coal mining back from when it was first brought out of the earth until today, a lot of people had to give their lives to pave the way for energy generation, making it one of the more dangerous professions over the ages. In fact, from 1900 to 2020, an estimated 104,895 people perished while mining coal in the U.S. alone, according to the United States Department of Labor. But considering that archaeological evidence after approximately 3,490 BC shows early surface coal mining in China, the number of lives lost worldwide throughout history is undoubtedly a far bigger number. In the first underground coal mines, miners toiled with primitive pickaxes and only a meager candle to light the area. The candle also proved dangerous, however, as it could cause pockets of methane gas trapped in the earth, referred to as fire damp, to ignite and explode, bringing certain death to any miner in the vicinity of the blast. Choke damp was another major concern, a form of stale air that could suffocate miners to death. Add to that the potential risk of flooding, which can and did happen regularly, and we can see that it was sometimes a roll of the dice for miners on a daily basis to determine if they lived or died. It was also very common to be in a permanent state of strain and injury from toiling with such heavy weight through awkwardly spaced mining shafts, so overall, life kinda sucked for early era miners. Now, it wasn't just the men that risked their lives, women and children had some of the worst of it, being forced to crawl on their hands and knees in tight areas of almost total blackness with a rope tied around their bodies from which they dragged extremely heavy carts of recently mined coal. They got this job because they were smaller in stature and more easily able to fit in the various crevices of the mine, but they sometimes never saw daylight at all except on Sundays, as they were underground from before sunrise to after sundown. In 1842, the Mines and Collieries Act was passed in the United Kingdom, which forbade women of any age and boys under the age of 10 from working in a mine. This came to pass after a mining accident caused by steam overflow due to violent thunderstorms left 26 children dead at a mine in the UK. Now, the initial solution to the problem of explosive gas was a special class of miners called firemen, who wrapped themselves in protective clothing and took shelter under panels of wood before purposefully igniting trapped gases with a long torch or a candle drawn on a string. They needed to do this multiple times per day to ensure the mine shafts were kept clear of explosive gases while the miners extracted coal. To say this job was stressful would be an understatement indeed. The coking of coal was first implemented in 1740 for the smelting of iron, and this made it much more economically feasible to produce it, resulting in a boom for the iron industry. The iron created by coking coal was then used to build more effective implements and technology to mine more coal. Modern coal mining has come a long way and consists mainly of three methods. Continuous mining employs remote-controlled monstrous machines with foot-long teeth called continuous miners to break through the earth and extract the coal. These devices can extract as much coal in 1 minute as used to take an entire day back in the 1920s. Longwall mining was first introduced in the late 1950s and has evolved a lot since that time. Like continuous mining, longwall relies on special machinery. Now, it's a little tough to explain, so here's a definition from the Dictionary of Energy. A mining method in which very long rectangular blocks of coal are defined during the development stage of the mine and then extracted in a single continuous operation by an automated cutting head moving parallel to the coal face. Surface mining became a viable method following World War II and eliminated a lot of the risks associated with underground mining by once again employing huge machines, but this time to strip away earth and reveal coal seams that lie closer to the surface. These machines, called dragline excavators, are considered the world's largest land-based machines and are a spectacular sight to behold. Surface mining is done in large open areas of land where coal seams can be readily identified and don't require going deep underground to uncover. In the days of ancient Greece, the great philosopher Aristotle described a rock that burns. Today, we know that rock as coal. Coal was used by many ancient civilizations: the Roman Empire, the Hopi Indians in early America, and the Chinese, to name a few. It was mainly used as a source of heat, but was also employed in baking pottery and the burning of funeral pyres.
Why am I here? It's like I'm breathing, but not really alive. My smile hides.
As early as 1215, sea coal began to be traded around Scotland and the northwest of England, where it was used by artisans for lime burning, metalworking, and smelting. Sea coal was often washed ashore from deposits below sea level and collected by hand to be traded. As forests were stripped bare of wood for heating and the construction of ships, the use of coal became a necessity, and so a quest began to mine it in earnest. If you think air pollution is bad in some parts of the world nowadays, as coal rose to prominence in towns and cities back then, it produced a black smog so dense that entire neighborhoods were sometimes enveloped, making it impossible to see clearly. Visibility turned out to be the least of people's worries, however, as inhaling such vast amounts of coal smoke killed many citizens before efforts were made to reduce and clean up its use. In fact, as recently as the 1950s, there were public health disasters resulting from the burning of coal, and the Great Smog of London swept over its namesake city in 1952, primarily driven by coal use. The government reported 4,000 deaths officially, but I've learned enough about how governments operate to place far more trust in the more recent research that indicates 10 to 12,000 civilian deaths from the killer clouds of coal dust. This crisis, and many others over the ages since coal came into regular use in the 13th century, led to the Clean Air Act of 1956. The act was enacted by the Parliament of the United Kingdom as a means of protecting the citizens from coal dust and other toxic particles in the air by mandating smokeless fuels such as charcoal, and included measures to reduce emissions of dust, grit, and gases from chimneys. The Industrial Revolution, spurred on by improvements in technology, brought about a massive increase in the amount of coal being mined, with production growing rapidly in response to this new demand. Coal was indeed king when it came to this era, and continued to reign in the Western world for a long time to come. British poet William Blake famously described coal-powered cotton mills as dark, satanic mills, and indeed the constant churning of smoke and layer of black soot on everything must have given many areas of England a dreary and intimidating atmosphere. Nonetheless, there was no other substance that could produce energy as efficiently or as cheaply as coal, and it powered not only the means of production, but also transportation. Great imposing steamships and sturdy railway locomotives were powered with great success, especially considering the existing technology of the time. It also fueled engines that drained water from coal mines, contributing to another full circle journey for the Black Rock, as it was turned into steam to power the engines and allow miners to travel even deeper, thus increasing the total haul of coal. Coal has provided a large amount of total energy production in the UK over the years, and even though its use fell from 156.89 million metric tons in 1970 all the way down to 900,000 metric tons in 2019, it still remains a large source of power, accounting for approximately 9% of total energy consumption in the United Kingdom. We've been focusing quite a bit on the UK because they have a longer recorded history of coal use than pretty much any other European country. But coal was, and continues to be, a large source of energy in the developing world. And despite all the hate it gets, it is still a necessary piece of the overall energy picture if we ever hope to get to a carbon-neutral future. This is because to upgrade to a technology like nuclear power, which is the most cost-effective and efficient low-carbon source of energy on planet Earth at present, developing nations need to climb the energy ladder and evolve their energy production by improving their country's economic situation before they can afford to shift to a less environmentally harmful energy source. As of 2019, the top consumer of coal was China, although they are currently striving very hard to advance nuclear, wind, and solar energy production, with plans to reduce the CO2 intensity of its gross domestic product by 60% by the year 2030. President Xi has committed to reduce coal consumption starting in 2026, but many other countries do not have that option if they want to have access to electricity in the years ahead. A recent 2-day virtual summit on tackling climate change, hosted by the White House and involving all the countries who agreed to the Paris Climate Agreement, has placed a big emphasis on a global shift towards carbon-neutral energy future, with an ambitious and some would say lofty goal of limiting global warming to well below 2 degrees Celsius, phasing out of use of coal, part of achieving that goal. As civilization moves forward, there will come a time when coal will be just a fleeting memory. But for now, it still has a role to play in our global energy economy. Thanks for watching Commodity Culture. See you next time. Commodity Culture is a series that covers the
Okay, thank you for those that have been watching. And I was following someone in the chat. Okay, so I was saying, thank you for those that have been following. You realize that that video was not a waste of time, especially if you're to pick any item that requires you to answer a question in this part. And not only that, but also for your societal development. Because I saw someone in the chat saying this is more of a history lesson. But if you are following, you would realize that this video has the production of coal, how it is mined, and also the problems that the people that carry out this process encounter, and also the social benefits. And you realize that the whole item was captured. That means in section B of your exam of paper 1, if you have a question on coal as a natural non-renewable source of fuel, you're going to notice that you may need to know, first of all, the components of coal, and then of course you'll need to know why it's a non-renewable fuel. And then of course you need to know what are the challenges, because if you look at the video, they kept looking at what are those challenges that people that mined coal used to encounter until there were those advanced machines. But even the advanced machines have their own challenges. When you use them, what are the challenges that are encountered? And then of course, on top of that, the challenge alone is not enough, but how was that challenge mitigated? How was it solved? How was it overcome? So if you kept watching, and like I said, if you had your book, you'd keep noting down some of those few things. And then of course they talked about the social benefits. How has coal been important, or how has it contributed to the what? To the society. So it is very important to watch these videos and also take down notes, because they always have a lot in them. Okay, so Mirage, you have a question? Tekna, I don't know what question you're talking about, because people are putting a lot in the chat, so I can't really keep track of what question it was.
Like, do we have tests about these Zoom lessons?
Do we have?
Tests.
Not really, but maybe I'll discuss that with the team, and I see if we can do that. Maybe it could help us gauge how far we've gone.
Okay, thank you.
Yeah, thank you for that. I think it's something to look into.
Yes.
Okay. Yeah, thank you. Bingo. Sorry?
Like why does call take long to like to why does it take long to be produced?
To do what?
Why does it take long to be formed?
Okay, anyone who can answer Bingo's question, why does coal take long to form? The people whose hands are up, are you willing to answer? Okay, let's hear from Vanessa.
Hello, sir. Hello?
Yeah, why does coal take long to form? That was Bingo's question.
So I was requesting if you can increase the volume. Me, I can't hear you.
I am asking, do you have an answer to Bingo's question? She is asking, why does coal take long to form?
No?
Okay, your hand was up. Was it for a question?
No, I was requesting if you can increase your volume. I can't hear you.
Maybe you may need to increase the volume of your device because I am extremely loud where I am. Try to check the volume of your device.
Okay.
Thank you. Let's hear from Atrick.
Okay, madam, I think. Hello.
Yes, I can hear you.
Okay, I think it takes long to become a coal because the process is takes place slowly.
Okay. That is very good. So the first video we showed about the formation of coal showed that the process is very slow. And then you also have to understand that the decay of these plants is not just putting there something and it rots. It has to decay over millions of years for it to actually form the fossil fuel that we are looking for. So being, I hope we've answered your question. Atrick, did you have a question?
Yeah, I had a question.
Mm-hmm.
My question was, in case it has become a coal and it is not mine, which product does it form?
Okay, anyone to answer that question? Let's hear from Maria.
It's natural gas.
Sorry? Zuriel, you said something?
It turns into natural gas.
Excuse me, sir.
Yes, Maria.
Yes. So with time, as coal is not mined, various transformations take place. Cause it becomes graphite and anthracite, then even natural gas is formed, and also a coal bed methane.
Okay, thank you. That's good. So Atrick can go and find out more on that, but basically it transforms to form other components that may be embedded within the what? The sedimentary rocks. Okay, thank you for those contributions. Maria, did you have a question?
Yes.
Mm-hmm.
My question was, for example, let's say fossil fuels is an item 6.7. So
5 and
for
6.
yeah, item 6.5 there. So if you're answering like that item about fossil fuels, is it required to put the formation?
Not really. Maybe if it comes as an item 4 and 3. Item 4 and 3 will require you to suggest the process of formation, because there it will have come as in another topic where we look at carbon in life, where we look at these different components. But
Yes.
otherwise, of course, after the topic, we are going to look at some of the scenario questions that capture these different fossil types, and then we'll see how to answer them.
Okay, thank you.
Ali, thank you too. Okay, let's hear from Zuriel. Zuriel, can you please unmute and ask your question such that you can move? Okay, let's hear from Atala.
Madam, I have a question. My question is that, so coal takes billion years to be formed, like to be formed out.
We said millions of years. That means there are several years that get into millions.
Okay,
Yes.
thank you.
Okay, thank you. Let's hear from Baby Boo. But I think we should use our names such that they don't sound funny in the recording when people watch the videos.
Okay, madam. I have a question. Good afternoon, madam.
Good afternoon.
My question is that when it comes as a question in item 5 or 6, and we are supposed to state the category, the composition, the benefits, and the dangers, right?
Yes.
Then when we're on the composition and we are all like, it's from a sedimentary rocks and we give the examples, are we also supposed to give these other kinds of rocks?
No, because even the sedimentary rock itself is not the composition. What is inside the sedimentary rock is what makes the coal. So when you're talking about the composition, we are basically looking at the elements that are inside that given fossil fuel. For example, I mentioned carbon, then of course hydrogen, nitrogen, and those others. But of course, the main component is carbon with those others that you need to mention. So you may not really talk about the different kinds of rocks.
Okay, madam, thank you.
You're welcome. So let's endeavor to attend all the lessons such that in our last lesson, we look at how to answer those questions. Irene? Irene, please unmute. Okay, Infinix 30. And I think I'll take one more question, then we'll resume. Infinix? Okay, let's hear from Scovia.
Okay, good afternoon, madam.
Good afternoon.
Yeah, mine is like if they bring a question and they talk about this and the category, how are we supposed to categorize them?
We will discuss that when we are discussing the question. Just endeavor to attend the lesson next week.
Okay.
Yeah, just look out for the timetable, attend the lesson next week and see how to answer those questions. In Phoenix, we are just hearing noise from your background. Can you please get a silent background and ask your question?
Example, important. Hello? Hello? Hello?
Okay, Infinix, I didn't hear your question. You kept saying examples of what? Okay, so we have a few highlights here, of course, depending on what we've watched in the videos and then what we may need for our summary of the notes that we've looked at today. So we've seen and noticed that coal takes long to form because it requires anaerobic decomposition. That means there should be no supply of oxygen for the decomposition of these plants and animal materials under heat and pressure. So that means coal requires that kind of condition for it to form. And then, of course, coal is mostly carbon, like I've been saying, with variable amounts of other elements such as hydrogen, sulfur, oxygen, and nitrogen. So those are some of the other elements that are important. So when you're talking about the composition of coal, you're looking at carbon, hydrogen, sulfur, oxygen, and nitrogen. But of course, it's majorly carbon, and that explains the reason why it's black. And then, of course, we have coal is formed from dead organic matter, which decays into peat and is converted to coal by heat and pressure of deep burial over millions of years. So, of course, this peat is exposed to intense heat and pressure, which definitely leads to the formation of coal. And then, of course, we know that coal is drilled from its deposits. That means the method used for obtaining coal from its deposits, it's drilling. Like we saw those different machines and the different machinery that was used at that site. Those are some of the machines that are used in drilling. And like we saw at the beginning of the video, you'll notice that people were digging using those hand axes. But eventually they had to what? We had to migrate depending on the increase in technology. So you realize that the machines were doing a greater job and in a shorter space of time than people who were just digging for the coal. And then, of course, even through the video, you notice that coal is basically used in power generation and it is cheaper when using it as a source of your power. And then, of course, it is also used in domestic use, maybe lighting, cooking. So coal may have those different benefits towards society. Someone is asking for key factors in coal formation. You need to understand that, first of all, there is anaerobic decomposition of plant and animal material. And then, of course, it is exposed, the pit that is formed is exposed to intense heat and pressure, which eventually form coal. That is basically it. There is nothing like a very lengthy process that you're waiting for that will actually lead to the formation of what? Of coal. Okay, so if there are any questions, we'll take them at this point before we look at crude oil. Isaac, if you're still a co-host, can you please help me in handling the hands that are coming up?
Okay, let's hear from Tori. Please unmute.
We are talking about the formation of crude oil, right?
Yes, go on.
Right. Crude oil is formed by action of heat and pressure on the remains of sea plants and animals over millions of years.
Okay, let's hear from Sharif. Sharif, unmute.
Madam, excuse me. Madam, during when we were watching the other videos, they talked much about the swamp during.
Okay, Sumaya, unmute.
Okay, may I have a question about composition of coal?
Okay, those are all good point outs, but I still see some hands. Can we hear from the rest of them as well?
Irene, please unmute. Okay, Irene has network problems, but Donna, please unmute.
I have a question. So, like at school, when you're learning about the social benefits of coal, our teachers usually tell us to for it to be easy when you're giving benefits of like resources, employment is key. So, is it right for us to put like it's a source of employment, like maybe if people sell coal and get money?
Okay, so it depends on what question you're answering and also which item you're attacking at that point in time. So like I said, at the end of this, at next week's lesson, we'll look at how to answer the questions that concern this bit that we are covering. So not to confuse people, I want us to have the question and we answer it together such that we correct those points. So can we be patient up to next week's lesson?
Yeah.
Okay, thank you. Okay, someone is asking for the previous slide. Okay, so looking at crude oil, I saw someone talking about fractional distillation. So we need to know when we are looking at formation and maybe obtaining the different components, because crude oil is obtained from somewhere before we take it for fractional distillation in order to get the different what? The different fractions. So that means when we are looking at the process of formation, we are not looking at the fractional distillation method. We are basically looking at the formation of that crude oil as a result of decayed matter over millions of what? Of years. And this matter is exposed to heat and pressure, whereby it forms that what? That crude oil. So, I think the person should just take a screenshot such that we can watch this last video before we close the lesson for today. And then, of course, we'll have to pick up from there. So the person who asked for this slide, please just take a screenshot.
You have to know that humans have been using fossil fuels for a very long time. Coal, oil, natural gas, propane, diesel, or other stuff. What does fossil fuel even mean? It means fossil fuel. Fuels that come from ancient fossils. Fossils that come from animals and plants. Creatures in the ocean or on land. Anything that died in history, it could be in the water or on land, remained on Earth. You know that bacteria attack any dead body. The bacteria eat whatever they can, and the remains is left on the ground. The remains that was left on the ground stayed for millions of years, and it entered the Earth's crust. And today, that fossil has turned into fossil fuels. The most famous fossil fuel that everybody knows and loves is oil. The first oil drill happened in 1859 in the state of Pennsylvania. This oil drill didn't really have value because they didn't really know what they could use this stuff for. They would pull around 3,000 liters of oil a day, and it was kind of worthless because there was not a lot of buyers. They would turn it into kerosene and use it for old lamps. But today, 90 million barrels of oil a day is pulled out of the ground. There's a question now. What does the Persian Gulf have that there's so much oil in there? Was it a jungle? Did the dinosaurs live here? All these are wrong. Millions of years ago, the entire Middle East was underwater. But there was a lot of places that was underwater. Why don't they have oil? Because the Persian Gulf was a special place that pulled everything towards it. Millions of years ago, the Persian Gulf was considered a basin. And that means anything that was in the water would be headed that way because a basin is kind of considered like a bowl, so everything is attracted that way. And that is why most of the fossil fuels like natural gas and oil is located in the Persian Gulf. Different parts of the world had this situation happen, and now they have fossil fuels. So if you get away from the Persian Gulf, you could say there's a lot of oil around Venezuela and Canada and the United States. We can't talk about the whole world, but we can put an example on Venezuela. This place, just like the Persian Gulf, was underwater, and it was also considered a basin. Venezuela was located in an area where all the bacteria, algae, plants, fishes, and any corpse was headed that way, and it was kept on the ground in that area. And that is why Venezuela, with more than 300 billion barrels of oil, has the biggest oil reserve in the world. After Venezuela, it's Saudi Arabia, which is around 266 billion barrels. These are oil that are very easy to access, and you can pull them out for a very low price. But there's another type of oil that it's between the rocks, and pulling it out is a lot more expensive. The process of pulling oil in between rocks or sands and dirt is called fracking, or it's also considered hydraulic fracturing. Fracking is not as easy as it looks, and it's not cheap to do either. If oil prices are low, it's not even worth it to do fracking, because pulling shale oil by fracking, it's around $50 a barrel. To pull oil in between rocks in the crust of Earth, first, they insert a type of liquid that's mostly water, and it puts pressure on the rocks and cracks them. After that, oil or natural gas can be pulled out from it. But the cost to pull out oil in the Persian Gulf is only around $10 to $20 a barrel. Before the US could start fracking, they were dependent on the Persian Gulf oil, and they had to buy it from them. But with fracking, they could get their own oil. But each barrel has to cost more than $50, so it's worth to do all this work. You could say Canada has a lot of oil, and it's very similar to Venezuela. But Venezuela has very easy accessible oil. Canada's oil has to be pulled from rocks and sand. And that is why Canada is not on the list with the most oil reserve. So why does the US and Canada have oil in between the rock? Or Venezuela and Persian Gulf is very easy accessible oil? Because the age of the fossil fuels in Canada and the US are a lot lower than the Persian Gulf and Venezuela. Scientists say if you wait a couple million years, Canada and the US oil is gonna be like Venezuela or the Persian Gulf. But obviously they're not gonna wait because they're very impatient. Since the day I went to school, they were saying that in 30 years, there would be no oil left. But this 30 years is not moving, and they're always saying 30 more years. The more we move forward, the more oil we find, and the reserves get bigger and bigger. But the more we move forward, our need for oil is less and less, and the main reason is the environment. They say fossil fuel is causing global warming. Right now, they want to lower the use of oil and focus on natural gas. And that's another fossil fuel, but with very low emissions. You have to know that the cleanest fossil fuel in the world is natural gas, and getting a hold of it is just like oil. You could use natural gas for everything as well. Anything you can make with oil, you could make with natural gas. Like for example, plastic. As you know, we're going towards electricity. So the main usage of power is going to be electricity soon. And natural gas has a very important role in this situation. The technology is moving towards jet engines that create electricity. Just like this jet engine, and it's called a gas turbine. It uses natural gas and it creates a lot of electricity. And the cool part is that the exhaust that gives the heat makes steam, and that creates electricity. Nowadays, jet engines aren't only in the skies, but they're creating electricity on the ground. Electricity that comes from natural gas, and the exhaust heat creates electricity as well.
Okay, so in our next lesson, we'll look at crude oil and natural gas and wrap up that part, and then look at some of the questions that we may interact with in this area. So as you go back, please read the notes that we've looked at. And in case you weren't able to pick a few things here and there, you can always get this video on the Help YouTube channel, Senior 3 Chemistry Help Lesson. So you can always rewatch those videos. And then, of course, ensure to read about natural gas and crude oil as we come in for our next lesson, such that we are all together. But thank you for being an active class. And I want to thank Isaac for helping me as a co-host and everyone that has really contributed to the success of this lesson. Thank you everyone for connecting for today's lesson. Have yourselves a lovely week.